everyone. Welcome to Atlassian Barcelona. So before I start, I want to run a quick poll to the audience. Hands up who's never ever found a web page being down. So I thought. Okay, so my name is Julia. I was born in Spain, which is here. And yeah, if a mole were to start digging a hole in the middle of Spain, a very deep, deep, deep hole that went all the way through the earth, it will eventually appear there in New Zealand. I live there in Sydney, which is pretty much the other side of the world to where I'm from, right? So can you imagine what happens every time I try to access my bank account in Spain from Sydney? It's down for maintenance. This funny picture here is the making of the Oatmeal, which is a quite famous webcomic artist. A few years ago, he encountered that Tumblr, the blogging social network, was down when he was trying to access it. So he got upset and he drew this picture. Later, when the site was back up, he posted this passive-aggressive blog post in his site saying, "Dear Tumblr, if you're going to go down, you might as well blame it on an imaginary animal like Twitter did with their infamous fail whale. I've taken the liberty of creating this animal for you. Please use it." The funny ending to this story is that eventually they came to use this Tumblebeast, as they came to be known, for their downtime page. But, well, we can agree that disruption can inspire creativity, but I think downtime is not the kind of disruption our customers are expecting from us, right? So let's talk about downtime. There are two kinds of downtime. One is the unexpected downtime that happens when something goes wrong, something breaks, our system is under attack. It's unexpected. And the only thing we can do about it is try to fix whatever is not working as soon as possible to have our service back up and running. And then there is the scheduled downtime, the scheduled maintenance window. And this is what this talk is about. It's about scheduled maintenance windows. So let's start by defining what a scheduled maintenance window is and why they exist in the first place. So as its name indicates, a scheduled maintenance windows is a pre-scheduled gap in time in which a maintenance operation is performed. So by pre-scheduled, I mean either it happens on a regular basis that the users are aware of, like every Monday at 3 p.m., or we've communicated well in advance to our customers, hey, we're going to have a maintenance window next Wednesday at 3 p.m. It's going to last an hour, whatever. During this time, we block our customers' access to our system. They cannot use it. And then a maintenance operation is performed like a database migration, or in this case, an application upgrade. The reason we block our users' access is because it's dangerous for them to access. It's safety reasons are the same reasons we are not allowed on a construction site. It's because a brick might fall on our head, or we might fall in a hole, or something might happen to us. It's dangerous. In the case of a maintenance operation, it's not our physical safety, it's the safety of our data. If we were allowed access to a site that's performing maintenance, we could see data corruption, data loss, unexpected UI behaviors. So it's just safer to block the access. But developers and software vendors don't like to have their site down, right? customers using their service is the reason they exist in the first place. So not letting customers use the service seems not a very smart move. So they try to mitigate as much as possible the impact on customers, usually by performing nightly maintenance windows. And this many times mean the developers have to physically go to their offices at night to perform these operations. So they sacrifice themselves for the sake of the users. But it doesn't really work, right? Because I'm in Sydney accessing my bank account on daytime, but it happens that it's night time in Spain, so they are down for maintenance, and I cannot perform my bank operations. And this is a trend that's more and more common every day. We are in a global economy. And in the case of JIRA, we have many customers that will have offices distributed across different geolocations. So their instance might be scheduled for maintenance when it's nighttime in the headquarters, but it's the middle of the workday for other of their offices. So our customers are telling us this is a problem. They're telling us that our weekly maintenance window is a nuisance, that their outages are too frequent, and it hinders productivity. We also have some data that up to 20% of our customers have users who might be trying to access their JIRA instance during a maintenance window because they are located in a geolocation where it's daytime or work time when their instance is scheduled for maintenance. So 20% is quite a big number. And aside from customer feedback on this data we have, in Atlassian we also have some company values, right? And one of those company values is don't fuck the customer. So if we know this is a problem for our customers, we have to fix it. So we started by looking to how our current maintenance upgrade window looked like. And it looked a bit like this. The little house there is the JIRA instance that's going to be upgraded. When the maintenance window starts, first thing we do is destroy it and kick the users they can no longer access. And then we spin the upgraded version that takes a while to be ready to start accepting requests, and only when it's ready, we let the customers back in again. A weekly maintenance window is scheduled for 3 hours, but actually for most of the customers, this takes around 30 minutes, which if happens every Monday in the middle of your workday is quite annoying, right? So we thought, well, this process seems a little suboptimal, right? Why don't we spin the new updated version before destroying the old one, then just switch the users and they won't even notice? We looked into it and realized that the architectural changes we will need to perform to achieve this would take us nearly a couple of years. We're still going to do it, but we wanted to fix the problem for users quicker, or at least give them a partial solution, because 2 years in software is like eternity. So we went for a compromise solution. We said, well, if we cannot have the whole instance ready, why don't we have it almost ready before destroying the old one? And then at least the wait time is going to be smaller. So that's what we did. The current process looks a bit like this. You have your instance that you're using, then we spin the new version. And when it's almost ready, it stops its startup process. And only when it reaches this point we destroy the old instance, wait a little bit more for the new one to be ready, and then let the users in. So the reason we couldn't go for the, let's say, proper solution, that they have the new instance completely ready before we destroy the other one, is because these two instances are going to be sharing resources. Some of these resources are safe to be shared, but others aren't. So we had to study which resources are there, and which ones are safe, and which ones aren't. And then we rearrange the startup process. So the new instance will acquire first all the resources that are safe, and only at the very end it's going to try and access the ones that are not safe. So at that point, when it tries to access the first non-safe resource, is when we stop the process of startup and destroy the old instance. So aside from rearranging the startup process of JIRA, we also had to orchestrate this new process that's a little bit more complex than we had before. Because before it was very straightforward. We destroy old instance, start new instance. Once it's ready, bam, we're done. Very simple. Now we spin the new instance, decide when it's going to try and access a non-safe resource, tell it to stop, then check if it's ready to go, destroy the old one, and then let the other one continue until it's ready, and we let the users in. But here what they say, I said, if it's ready to go, we destroy the old instance. This is something we didn't do before. Before, first thing we did was destroy the instance. If something went wrong, there was no going back. So we're getting here a great opportunity for recovery points, for preventing failures to happen, because if something's wrong with the new instance, the users will never realize they are going to be using the old one. This is the time that users have for downtime now. We're coming from around half an hour. We are now around 30 seconds, which seems a huge win. So numbers. So as I said, 90% of our instances have a downtime of less than 32 seconds now, compared to the half an hour they had before. Most of them are actually below 24 seconds. And this has interesting implications that we're going to see after. But aside from that, in these around 30 seconds, 90% of the instances only have 2 affected requests, 2 or less. Affected requests mean that someone's trying to perform an operation right in the moment in which you are being switched from one instance to the other. Of those affected requests, actually, most of them succeed. They're going to be slower because these requests, what happens to them is they're put on hold until the new instance is ready to attend them. So they're going to be slower, but most of them, a great majority of them, are actually going to succeed. The rest, they're going to get the old, sorry, we're down for maintenance page. But we still have a year and a half to fix that. So implications. We were having a weekly maintenance window, a weekly upgrade. We can now make the decision of having daily releases. And if we have 5 times the number of releases in a week, we're going to still have a tiny, tiny fraction of the total downtime we had before. So this has enabled us to do this. And of course, this has great implications on dev speed. Because before, our developers sometimes were like, if I don't put my changes in before Wednesday, it's not going to go to the next release, so I have to wait another whole week, and then there's this other team waiting to gather stats from my features so they can make a decision on the product roadmap. They were not focusing on what they had to focus on. Right now, they don't have to worry about that anymore. If their changes don't go in today, they're going to go tomorrow, so they can do what they do. They can focus on fixing bugs and creating new features, be creative, do their thing, right? Also, by having more releases, it means each release has less changes. We're putting our eggs in more baskets. So these releases are less risky. And even if something goes wrong, it's much easier to identify which change was causing the failure. Also, we are delivering more often. So customers see their bugs fixed earlier. Also, we have a faster dev loop because we can gather feedback from users more often, so we can correct course or for roadmap, whatever, if we see something's not working as expected. So yeah, we wanted to fix one problem our customers had that was too much downtime, but we ended up with many wins on the way. So effectively, we got less downtime, but we also got less risky release. We got our developers more focused. We started to bring value to the customers much more often. So in a single move, we made both our customers and our developers happier, which is great. So thank you very much.